The distance we measure in space separating the two masses is the same distance. The distance from the first mass to the second mass is equal to the distance from the second mass to the first mass. But the value of the gravitational force is not just inversely proportional to the distance separating the masses. If so, it would demonstrate a relationship only between something static still. The fact that the gravitational force is inversely proportional to the square of the distance. The fact that the gravitational force is inversely proportional to the distance times itself demonstrates that one mass acts on the second mass in the same way that this second mass acts on the first, and reveals even more. Informed that it is only through the distance that the interaction between the masses occurs, that it is through the continuous empty space that the transference, the modification in the movement between the masses occurs. The relative amount of movement, of oscillation in the tension of empty space that every mass is, causes the tension of empty space to vary around itself, altering the situation of movement of another mass that with that field interacts, and which is another relative amount of movement, of oscillation in the average value of the tension of the space, and that also moves, or makes the tension of the space around itself vary, transferring movement to the first mass that also changes its movement. All these relative motions through space, whose influences are always exactly proportional to one another, reveal the same nature of all the physical concepts involved, the extension and continuity of empty space. Space and time are continuous. Space and time are not made up of particles. They are not discrete or grainy. There are no minute particles or indivisible and absolute minimum quantities of space and time. In this way, space and time are only quantum towards us because we measure them, but they are not so in their natures. The quantification of space and time is never absolute. It is relative. It has more to do with our physical inability to continue measuring them in extreme situations for us than with their physical nature. A good physical definition of time is that time is nothing more than a standard relative amount of repetitive motion. If, when we try to divide time into smaller and smaller pieces, we arrive at a point where we can no longer measure or observe any movement, at a point where the idea or notion of movement is no longer observable, it is clear that the concept of time also loses the original meaning that we give it, the original function that we attribute to it, ceasing to mean anything to us. In order for empty space to exist for an observer instead of nothing, he needs to use some kind of movement to be able to measure it. It needs to go out from a well-defined position in empty space and go to another position also well-defined, to have the concept of a straight line, one of the simplest idea constituents of space. If when we try to divide the space into smaller and smaller pieces, we arrive at a point where we can no longer measure anything through movement, we arrive at a point where we can no longer verify the existence of the idea. It is clear that the concept of space in this situation also completely loses the original meaning that we give it, the original function that we attribute to it, and ceases to have any meaning for us. The most natural way to measure anything is to look at it. So we use the reflection of light to measure things. But visible light, which is a movement, a relative oscillation in the tension of empty space, always has a certain well-defined wavelength. This measure of very small length, the wavelength of visible light, represents one of the physical barriers to our physical observation of very small things. We can observe indirectly through instruments, but even this form of observation is limited by very short wavelengths that make it impossible to physically observe things that are even smaller than that.